Well, we can use similarity to calculate unknown distances. If we know a smaller distance and we have similar triangles, we can create pairs of them and use the ratios to calculate the large unknown distances. So let's have a look at an example. We've got a guy who's 1.8 meters tall and he's casting a shadow 1.2 meters long. There's a tree nearby casting a shadow as well, and we want to know the height of this tree. So let's have a look. I'm going to go through first of all and just jot onto my scenario all the distances and things that I do know. I've got my little fella here with his shadow 1.5 and he is 1.8 meters tall. Here's the shadow of the tree, 20 meters, but it's this bit here, the height of the tree, that is unknown that we'd like to calculate. I'm going to go through and I've drawn up a little geometrical diagram to represent the situation. And you'll see in this diagram I have two similar triangles. I've got this small triangle here, and overall I've got another larger triangle. And I know they're similar because of the proof angle, angle, angle. Let's have a look at those three angles. This angle here is obviously the same for both because it's a common vertex to both triangles, so that angle is definitely the same. This 90-degree angle and this 90-degree angle are corresponding angles, so they are the same. And because I've got two, I know and I can assume that the third must be the same, and these angles here are corresponding. So they are definitely similar triangles by angle, angle, angle. So now I can proceed to work out some ratios, because we know in corresponding triangles, in similar triangles, that the ratios of the corresponding sides are all the same. Now we're going to use that information to work out our unknown tree height. The ratio of these two corresponding sides here is the long 20 meter shadow divided by the short 1.5 meter shadow, and that should be the same in ratio as these two corresponding sides here. Now this is my unknown one called x, so I'm going to just pop a value, a pro-numeral in there called x, over 1.8, which is the height of my man. So in other words, we're saying the height of the tree divided by the height of the man should be in the same ratio as the shadows. Now that I've got this nice little equation here, I can use a bit of algebra to get x on its own, which is the value we're trying to calculate. Multiplying both sides by 1.8, I get a value for the tree height of 24 meters. So without actually having to get out and throw a tape measure over this tree, we've used similar triangles to calculate the height of our unknown tree. Well done.